Now let's consider communication what? Principle. Communication principle. Now, on communication principle, our interest to be what? Questions and what? And answer. So this is a kind of an expository class, and it's a kind of a class where you'll be exposed on the questions, how you are going to see your questions for what? For communication principle. Now the questions are basically two sets. You have your section A and you have your section B. So in each section you'll be asked to answer maximum of 2 or maximum of 3, depending on how or the bulkiness of your what, the bulkiness of your what, your question. Am I communicating? Now for your section A, you simply have question 1, question 2, and question 3. Am I communicating? Now let's talk about the first question which we have here. Now what are we seeing? We are basically seeing that what they are asking you that what is the difference between communication and what? Telecommunication. What is the difference between what? Communication and what? Telecommunication. And what do you understand by the term modulation? So basically what you have here is what? Two questions, like 2 in 1 question. That's what you have. You simply have what? 2 in 1 question. Here they want to know the difference between when you're talking about communication and when you now add tele to your communication. What is the difference? Then the next question which you now ask is what do you understand by the term modulation? In essence, they are trying to ask you to describe what modulation is. But it should not be a kind of a bulky description, a kind of a brief description with points. Am I communicating? Now, on this aspect of our tutorial will not focus on the theoretical aspect of this course. When I mean theoretical aspect, I don't mean the definitions of different parameters which we have here. We are going to dwell on the calculative aspect of this course. Am I communicating? Now, what is the difference between telecommunication and what? And communication. Sometimes your lecturer will give you this question and he or she will expect you give the same thing he has taught you guys. Am I communicating? That's why we are not going to dwell more on what? On the theoretical aspect of this course. But in a case where your lecturer have not given you what communication is or what telecommunication is, you can grab the definition from the channel. Am I communicating? Here I actually listed what the difference between what? Telecommunication and communication. Now on the other aspect of the question, on the other part of the question, I briefly define what modulation is all about. Am I communicating? So you can do well to pause the video and go through your different theoretical aspect of the course, which is what we have here. Now for the calculative aspect of the course, we were given a question. This is also question 1. Now for your question 1, what is it saying? It says what? A carrier wave Y frequency, a carrier wave of what? Y frequency is given to be what? 10 millihertz and the peak voltage of what? 10 volts. Now what did they say? The peak voltage is now amplified to what? 6 volts. Is now what? Amplified to what? 6 volts. Now what are they now asking you? They said determine the modulation index. Determine the modulation index and draw the what? Amplitude spectrum. Determine what? The modulation index and draw the what? Amplitude spectrum. This is also 2 in 1 question. The first question is you are to calculate for your what? You are to calculate for modulation index, and the next one is you are to use the parameters which you have here to draw your what? Amplitude spectrum. Are we together? Now, what you first do is you were asked to what? To calculate or determine the modulation index. What you should ask yourself is what is modulation index denoted to be? What is the denotation for what? Modulation index. Now modulation index is what we are to find, right? We are asked to calculate for what? Modulation index. So you can put it down, your data. You can put down your data. Now the first thing which you were asked is what? Modulation index. Modulation what? Index. And your modulation index is denoted by what? Small letter m. and we don't know this parameter. What's the next one? Remember, from the first thing we have here, they said a carrier wave Y of its frequency 10 millihertz. What is that telling you? That this is simply telling you that you are giving what? A carrier frequency. So we have a carrier frequency, a carrier what? Frequency. So we are giving a carrier frequency here. And we said a carrier frequency is given to be what? 10 millihertz. Am I communicating? Now, what's the next thing we are now giving? You now say the question now says what? And peak value. And peak value to be what? 10 volts. Now, what are they asking you? What did they give you here? They are simply giving you what? Peak voltage in that case. So your peak voltage, your peak voltage here to be what? Your V what? Your peak voltage VC is now equal to what? 10 volts. And is what? Amplified 6 volts. Now, when we are considering amplification in this course, amplification simply tells you that what happens is you are giving what? You're modulating what? Voltage, or what? Modulation voltage. When you hear what? Amplification or amplified in this course, you should have it in mind that you are giving what? Your modulation what? Voltage, or the modulating voltage. And what's that voltage? Your modulating voltage was given to be what? 6 volts. So what do you have here in essence? You are going to have your modulating voltage. Your modulating what? Voltage. And your modulating voltage is given by what? V of what? M. And V of M is what? 6 volts. Now, what is now the next thing? The next thing is to what? To determine your modulation index. So what comes to your mind is, how do I determine modulation what? Index? Simply go over to your material or the notes you have. You will see that you have parameters. You have an equation that has to do with the parameters which you know here. What are the known parameters? FC, which is carrier frequency, VC, which is what? Peak voltage, and VM, which is what? Modulating voltage. So what you are going to look out for is, what equation will I use that has this parameter in it? Am I communicating? Now remember, there was an equation that was given to be what? Your M is equal to what? VM over what? VC. Where your VM is what? Modulating voltage. Your VC is your what? Carrier what? Carrier what? Carrier voltage, or your peak voltage. Am I communicating? And this will be equal to, what is your VM? Your VM here is what? 6 volts. And what is your VC? Your VC is actually what? 10 volts, right? Now, if you have 6 volts divided by 10 volts, this will actually give you what? 0.6. And 0.6 is your what? Your modulation index. So you've calculated for your modulation index. Now, what's the next thing? The next thing is to what? To draw the amplitude what? Spectrum. That's the next question. Use these parameters that you have here. Use the parameters that you have here to draw your what? Your what? Your amplitude what? Spectrum. Now let's go over to what? Amplitude what? Spectrum. That's the next question we are to solve in the exam. Amplitude spectrum. So let's consider amplitude what? Amplitude spectrum. Now, when we are considering an amplitude spectrum, when we are considering what? An amplitude spectrum, there are 3 things we need to note. When you are considering an amplitude spectrum, there are 3 things your amplitude spectrum consists of. Now, the first one is what we call the carrier frequency. So, number 1, for your amplitude spectrum, when you are talking about amplitude spectrum, there are 3 things you are going to see in your amplitude spectrum. The first one is what we call the carrier frequency. The carrier frequency, you must have a what? A carrier frequency. which is denoted by what? FC. That's the carrier frequency. Number 2, you must have what? An LSB. The next one is what? An LSB. LSB. Now somebody will ask me, sir, what is LSB? LSB simply stands for what? Lower sideband. Lower what? Sideband. So your LSB here simply stands for lower sideband. And sometimes they will not actually give you the meaning of LSB. What you now see is an equation for what? LSB. And what's that equation? The equation for LSB is now FC minus what? FM, where you are subtracting your carrier frequency from your what? Your modulating what? Frequency. Am I communicating? Now the next thing which you have to expect, or the next thing which you have to see when you are considering what? Amplitude spectrum, is what we call the USB. So the third one here, we simply have what is called what? The USB. And what's this USB? The USB simply stands for what? Upper side band. Upper side band. And your upper side band equation is given as what? FC plus what? FM. Am I communicating? So sometimes you don't actually see your LSB. What you just see is the equation for what? LSB, or the equation for what? USB. Both of them are sideband. Both of them are types of what? Sideband. Am I communicating? Both your LSB and your USB are what? Are a good example of when you want to classify, you want to talk about the types of sideband. You are now going to bring out your what? Your LSB and your USB. So in essence, both of them are still what? Sideband. Am I communicating? Now, how do you now represent this? How do you now represent this in your what? Amplitude spectrum? Amplitude spectrum. Now, when you are asked to draw your amplitude spectrum, they are simply telling you to draw a graph. Draw a graph that consists of what? Your amplitude and your frequency. A graph of what? Amplitude and what? Frequency. In essence, they are telling you to draw this. This is your graph. Sorry, it will not be straight the way you think it will be. So on this side of your graph, you have your what? Your frequency. And your frequency is in what? Millihertz. On this side of your graph, you now have what is called the amplitude. The what? The amplitude. And your amplitude is in what? Now, what you ask yourself is, how then do we represent these parameters that the amplitude spectrum consists of? The first one is our carrier frequency. Where can we represent our carrier frequency on the graph? Now, take this down. Your carrier frequency, divide the graph into 2 equal halves. Your carrier frequency, divide the graph into 2 equal halves. So basically, you have your carrier frequency at this point. So your carrier frequency is dividing this graph. So what you have here is what we call the FC. And the FC is what? The FC is basically what? Your FC here. What's your FC giving? Your carrier frequency. And from your carrier frequency, what do you have here? You simply have your carrier frequency to be what? What we have here, 10 millihertz. Am I communicating? So you are going to represent that on our graph. So here we now have what? We have our 10 millihertz. This is the work of our carrier frequency. Now, after your carrier frequency has divided the graph into 2 equal halves, this part of your graph is what we call the LSB. So this part of your graph is what we call the LSB, and this part of your graph is what we call the what? USB. Am I communicating? Now, sometimes you will not see this. You just see the equation for it, which is what? FC minus what? FM. And on this part of the equation, we now have what? FC plus what? FM. Am I communicating? Now remember, we are giving what? A peak voltage. A peak voltage. And we said, what's that peak voltage? 10 volts. 10 volts. Look at our question. We are given what? A peak voltage here to be what? 10 volts. So now you go back to your amplitude spectrum. You go back to your amplitude spectrum. Now, where do you think your 10 volts is going to be? This is the peak. This is the highest point of your graph. This is the highest point of your graph. So in the place where you are seeing your what? Your carrier frequency, that simply tells you that you have your peak voltage there to be what? 10 volts. 10 volts. Now, are we done? We are not done. Now, why are we not done? Is because for our LSB, or our USB, we don't know the amplitude of both sideband. Am I communicating? So how do you think we are going to get the amplitude of the sideband? Remember, the amplitude that we are giving here, this is called your modulated what? Voltage. This was not an amplitude. This was a modulated voltage that was given to you to be what? 6 volts. Now you have to get the amplitude for your sideband. You have to get the amplitude for your LSB and to get the what? The amplitude for your what? USB. Now how do you go about that? Now remember, when we are talking about sideband, on our last class, on our last physical class, I gave you an equation that says what? I gave you an equation that says VC, VSB, sorry, this marker is actually not good enough. Sorry. Let's erase this. Now, on our last physical class, I told you that for you to calculate for the amplitude of your sideband, we use an equation called what? VSB. Voltage of your what? Sideband. That's the meaning. And we said your voltage of your sideband is simply what? Modulation index multiplied by what? VC, which is what? VC is what? Carrier voltage divided by 2. Am I communicating? So this is the equation for your equation for you to use to calculate for the voltage or the amplitude for both sideband. Now, what is your M here? Your M here is your modulation index, and we've calculated for modulation index. We said our modulation index was given to be what? 0.6. So you take your modulation index back to your equation for what? VSB, which is voltage sideband. Your VSB now will now be equal to 0.6 multiplied by, what's your VC? We had our VC. They gave us VC from our question. We are giving our VC here. And what's your VC? Your VC is 10 volts. VC is what? 10 volts. So you simply have your 0.6. You simply have what? 0.6 multiplied by what? 10 divided by what? 2. And if you punch that with your calculator, you simply arrive at what? This will actually give you what? 3 volts. So in essence, you have your VSB, to be what? 3 volts. Am I communicating? Now, from what we have here, you've already gotten your what? Your voltage, like the amplitude for your sideband. Now remember, what we calculated was what? The voltage, that's the amplitude for sideband. We did not calculate for amplitude of lower sideband and what? Upper sideband. I said when you are considering the types of sideband, we are now going to consider your lower sideband and your upper sideband. But if you are putting the two of them together, they are what? They are both what? Sideband. Am I communicating? So the amplitude you got was for what? Both of them. So from your graph, if you want to represent this in your graph, you simply put this here. Let's say this is your 3 volts here. This is your 3 volts. So you have your 3 volts here. Now, how will your graph look like? So from here down to this point, and from this point down to this point, will now act as your what? Your 3 volts. Am I communicating? So basically you have your 3 volts in this space here. So you've actually calculated for the amplitude of your what? Of both sideband. Am I communicating? Here we know the we know FC. We know FC to be what? 10 volts. FC has what? 10 what? 10 volts, or what? Your FC here is, you know your FC here to be what? 10 millihertz. Sorry, it's not volts. So you know your FC here, your carrier frequency to be what? 10 millihertz. So in essence, we can say this. We can put this part of your graph to be what? 10 minus what? FM. We don't know our modulating frequency, but we know our what? Our carrier frequency here. On this part of the equation, you can say what? 10 plus what? FM. Am I communicating? So this is what we were asked to what? Draw. This is your what? Your amplitude what? Spectrum. Am I communicating? Now what's the next question which you are given? And the next question was actually for you to calculate. What's the next question? Now the next question says what? They were asking you, an AM broadcasting station operates at its maximum allowed total output of what? 50 watts. Allow a total output of what? 50 watts at 95% what? Modulation. At what? 95% what? Modulation. So in essence, your given parameter from this question, let's take down our given parameter. So our given parameter here, your data, you are given what? Your power output, and your power output can be denoted by what? PT. Your power output can be denoted by PT, and your PT is given to be what? 50 kilowatts. Now what are we given again? We are given modulation index, and I said your modulation index there is what? 90%. So what do? You convert this to decimal by saying what? 90 divided by what? 100, and that will give you what? This will give you 0.9. Am I communicating? 0.9. Sorry, we are having what? We have what? 95%. 95%. So if you have 95%, this will be 0.95. So you make that correction. This is 95%. So this is 95 divided by 100. Am I communicating? Now, what are they now asking you? They said, how much of its transmitted power is intelligence? How much of its transmitted power is what? Intelligence. What are they now asking you to calculate for? They're not asking you to calculate for what? Your PSB. Your PSB. They're asking you to calculate for what? PSB. And what's your PSB? Your PSB simply stands for what? Power in the what? Sideband. Power in the what? Sideband. And we know that when we want to calculate for PSB, PSB is given with the equation. PSB is equal to PT plus what? We have PSB to be PT minus PC. That's your PSB. That's the equation for your PSB. But now, how do we now calculate for PSB when we don't know what is what? PC. Am I communicating? Now, what do you do? What you simply do is to recall. Recall that we had an equation that says what? We have an equation that says PT is equal to PC into 1 plus what? M squared divided by 2. Can we remember this equation? Where we said what? Our M is what we call the modulation what? Index. Your PC is your carrier power, and your PT is your what? Your transmitted power, or your what? Total power output. Am I communicating? Now, from what we have here, we can see that we were giving our PT here. We are giving PT here to be 50, right? And this is equal to, we don't know what is PC. but we know what is modulation index, and we said this is 1 plus what 0.95 squared divided by what 2. Now what you do is you simply punch what you have here in your calculator, and if you do that, you simply have that your 50, which is your 50 kilowatts, is equal to PC. And what do you have? Punching your calculator, you get a value 1.45125. You can correct check your value with your calculator. Now after doing that, the next thing is to make PC stand alone. So what do? You divide both sides by what 1.45125, and divide on this other side of the equation 1.45125. Now what do you have? This is simply removing this. So you are now left with PC. Your PC now be equal to 50 divided by what 1.45125. Am I communicating? And what will you have? That will simply give you what? That will simply give you 34.45 kilowatts. So it's simply giving you what 34.45 kilowatts. You can correct check that with your calculator. Now remember, we've gotten your PC and you've gotten your PT. So you can calculate for your intelligence what transmitted power. And you said your intelligence transmission power is also what your power in the sideband. That's what you were asked to calculate for. So your PSB will now be equal to what's your PT? We now have PT to be what 50 minus, you now know your PC here to be what 34.45. So you now have 34.45. So in essence, you now have 50 minus 34.45, which will simply give you what 15.55. So this will simply give you what 15.55 kilowatts. Am I communicating? So your intelligence transmitted power will now be what? Will now be what? 15 kilowatts. So that's the simple calculation, or this is a simple way to calculate for your intelligence transmitted what power. Now, what's the next one? The next one is what we have the question 2. You'll be given question 2 also, and you'll be given some series of questions, and you have to answer all of them for your question 2. Now, what's the first thing we have here? This is what briefly explain the communication process involved in a GSM to what GSM communication between your caller and your receiver. This question is a theoretical question. It's just for you to explain what happens when your caller dials his or her phone and the receiver receives the call. What happens? What is the process that go on? What happens between the caller and the receiver for a mobile what communication, or a GSM to what GSM communication? That's what they are asking you to explain in essence. Now, what I have here, the question to this answer is actually, now I said, in a GSM to GSM communication, that's mobile to mobile call or mobile to mobile message, there are some steps that are involved. The first one is what we call the call initiation. Now, what happens is, on the call initiation, the caller dials the mobile phone, and signal is being transmitted to your base transceiver station. Now, note all these things. Note when we are talking about BTS. Sorry, let's put it here. Let's put it somewhere here. So note when we are considering what is called your BTS, your BSC, and your MS. Note these things. So sometimes they would actually bring up BTS, your MSC, and your BSC, and they now tell you what is the meaning of these words. Am I communicating? So you should know that when we are considering your BTS, you are talking about your base transceiver what station. Your BTS is base transceiver station. Yes. Your BSC is your what? Your base station controller. Your base what? Station controller. Then when we are now considering the last one, which is your what? Your MSC. Your MSC simply stands for what? Your mobile switching what? Center. So these are the various steps that these are what I've listed out here is actually what the steps involved for what GSM to GSM communication. So what you do is you do well to go through them. So the first one we have there is what call initiation. The second one we have there is what call routine. The third one is what tagging process. Tagging process. The next one which you have there is what we call the call what establishment, and the last one which you have there is what call termination. Call termination. Now what happens is on the call termination, after everything has happened, what now happens is when the either what I have here is either the caller or the receiver will now actually what end the call. Am I communicating? So these are the steps that involve in what GSM to GSM communication. What's the next thing? What's the next question we have there? The next question is a kind of a proved question. You have to prove that your carrier power is two-thirds of your what? Transmitted power. That's what you are asked. You are asked to prove that your what? Your carrier power is what? Two-thirds of your what? Your transmitted power. Now how do you prove this? How do you prove this? Remember or recall, we said what our PT is equal to what? PC over what? PC into 1 plus what? M square over what? 2. And what is your M here? Your M simply stands for your modulation index, your PC simply stands for your carrier power, and your PT simply stands for what? Your transmitted what? Power. Now, in a case where we are not giving your modulation index, you take your modulation index to be what? 100%. You take your modulation index to be what? 100%. So what do you do? At 100% modulation, you have that your what? Your at 100% modulation, you now have that your M is equal to 1. Why we got this one is because when you say 100% modulation, this is simply telling you 100 divided by what? 100. And this will simply give you what? 1. So now, in essence, in a place where we are seeing what? Modulation, M, we have to input what? 1. So you now have your new equation to be PT is equal to PC into 1 plus what? 1 square divided by what? 2. That's what you are going to have. Now, if you simplify what you have in your bracket, this will simply give you what? PT is equal to what? PC. What you have here is the same thing as writing 1 plus what? 1 over what? 2. Because if you do 1 square is simply what? 1, right? So what you have here on this bracket is simply, sorry, let me change the ink so it will be very clear to us. So we have 1 plus what? 1 over what? 2. This is the same thing as writing what? 1 over 1. Now the next thing we do is to get the LCM. What's in the LCM? 2 is the LCM, right? So we have 2 divided by 1 is 2. 2 times 1 is actually what? 2. Plus 2 divided by 2 is 1. 1 times 1 is now what? 1. So we have 2 plus 1 divided by 2, and this will give us what? 3 over what? 2. Am I communicating? So we've gotten your 3 over 2. What you do is you impute your 3 over 2 back to your question. So you simply have your PT to be equal to what? PC, and this is equal to what? 3 over 2. Am I communicating? Are you done? No, you are not done. So now what do? Your interest is make your PC stand alone. Making PC stand alone, you are dividing both sides of your equation with what? 3 over 2. So if you do that, you simply have PT divided by what? 3 over 2 and this is equal to PC 3/2 here divided by what? 3/2. Such that when this cancels this, you are now left with what? Your PC to be equal to what? PT divided by what? 3/2. Now, are you done? No, we are not done. We can simplify what we have here by inverting your 3/2. And when you invert your 3/2, your sign changes to what? Multiplication. That's elementary math. Now, if you do that, you simply have your PC to be equal to what? PT multiplied by what? 3 multiplied by 2 over what? 3. Now, what's your final answer? You now have that your PC will now be equal to what? 2/3, because the cumulative component. Cumulative component is, if you do 1 times 1, it's same thing as 1, or if you do 1 times 2, it's same thing as 2. If you do 2 times 1, it's still the same thing. So instead, we can take this to the initial part here, and we take this down to this place. So we have 2/3 multiplied by what? PT. Now look at what you've proven here, and look at what your question is. Are they the same thing? Yes. So your carrier power is 2/3 of your what? Your transmitted power, or your what? Output power. So that's what you are asked to do in this part of your question. What's the next question? The next question is actually for your question 2. This is the C part of your question. Now, what are they saying here? They said what? A 50 watts carrier. A 50 watts carrier. That tells you that you have your what? Your carrier power is modulated to a 90% what level. This 90% here is telling you that what? You have your what? Your modulation index. Am I communicating? Now, what are they saying? They say determine the total transmitted power. Determine what? The total transmitted power. When we are talking about total transmitted power, what are we talking about? Is it not PT? Yes, we are talking about PT. So basically, from your question, you're giving data. Your data here should be, you are giving PC, your carrier power, to be what? 50. What are we giving? Modulation index to be what? 90 what? Percent. And 90% will tell you that this is 90 divided by what? 100. And you have what? 0.9. What you are now asked to calculate for is what? To calculate for your PT, which is the transmitted power. Is your node. So calculating for transmitted power, remember our equation PT is equal to PC into what? 1 plus what? M squared over what? 2. So what do? You simply have that your PT will now be equal to 50 or 500, sorry. So we have your 500 here, your 500 watts into 1 plus 0.9 square divided by 2, and you get your what? Your answer. You get your what? Your answer. So what do you think your answer will be after punching your calculator? So you simply arrive at what? You arrive at 702.5 watts. So finally, your final answer will now be what? PT is equal to 702.5 watts. Let's consider question 3. Question what? 3. Now remember, we are still in section A. Your question 3 simply says what? The first question which we have there is what? Derive an expression for your AMDSB. AMDSB. Now, what's AMDSB? AMDSB simply stands for what? Amplitude modulating for double sideband. Amplitude what? Modulation for your double sideband. So your AMDSB simply stands for your amplitude what? Modulation. Amplitude modulation for your double sideband.
Now, what are they telling you? What are they asking you? They're asking you in this question to derive, to prove an expression that shows that, okay, this expression, this equation is an equation for what? Your AMDSB, which is your amplitude modulation for your double side band. Am I communicating? Now, let's go over to your answer. Now, what I did was actually I highlighted some steps or some approach for you to use to express your AMDSB. Now, without wasting time, let's go into the steps. Now, the first step is what we have to be what? Start with your carrier signal. So you're basically starting the process with your what? Your carrier signal. Now, what is your carrier signal in this case? Your carrier signal, which is denoted by what? C of t, is equal to what? A subscript C cos what? W subscript C of what? T. That is the meaning. So what we have there is, the parameters we have there is your CT here. The CT you are seeing here simply stands for your carrier signal. Your AC simply stands for what? Your carrier what? Amplitude. While your WC, W subscript C simply stands for your angular, you can call it carrier angular frequency. So this is called what? Your carrier angular what? Frequency. And your carrier angular frequency is given by what? 2 pi fc. 2 pi fc. Now drop what is what? F subscript C on the comment section. I've told you that. So what you should have in mind is, take note of all this equation. Take note of all this equation in case you are giving some values to slot in. So if you are giving some values to calculate for your carrier angular frequency, you should know the formula you have to use. And what's the formula? The formula is simply what? 2 pi what? Fc. What is your FC? Drop it on the comment section. Now, this is your step 1. Your step 1 says what? Starts with the carrier signal. We've already known the equation for your carrier signal. How do we go about it? Now, your step 2 simply says what? Define the modulating signal. After getting your carrier signal, what is now your what? Your modulating signal. Introduce your modulating signal. And what's your modulating signal? Your modulating signal is simply what? M of t is equal to AM cos WM subscript M of what? T. M of t is equal to what? A subscript M cos what? W subscript what? M of t. Now, what is your parameters there? This AM simply stands for amplitude modulation. Amplitude modulation, not message amplitude. This is wrong. This is wrong. So your AM there simply stands for amplitude modulation. Amplitude modulation. Your amplitude modulation, or your modulating, or your modulated amplitude. Now, your modulated amplitude here is your what? Your AM. While your W subscript M is what we call your amplitude. No, it's not amplitude anymore. It's now what? Modulating frequency. Modulating frequency. So this is your what? Your modulating frequency. Take note. So this is your what? Your modulating frequency. And what's your modulating frequency? Your modulating angular frequency. You add the word angular. Angular should be there. Angular should be there. So this is your what? Your modulating what? Angular frequency. And it is given by 2 pi fm. It is given by what? 2 pi fm. Now, what's your fm here? Your fm simply stands for your modulating what? Frequency. Take note, your W subscript M is what? Angular modulating frequency. While your FM is your what? Your modulating frequency. Now, this is the second step. The first step is your what? To start with your carrier signal. Define your carrier signal. The second step is what? Define your what? Your modulating signal. What's the third step? The third step simply tells you what? To define your modulation index. Now, remember, from our initial calculation, we did what? Modulating index or modulation index to be equal to what? V of what? M divided by what? V of what? C. Where your Vm is your what? Your modulating voltage, and your Vc is your what? Your carrier voltage, right? But in this case, we are talking about amplitude modulation of what? Double sideband. So we are not asked to use this equation anymore. We don't have anything to do with what? Voltage. What we have, the parameters which you will be considering here is your what? Your amplitude. So your modulation index for your amplitude modulation is now given to be what? A subscript m divided by what? A subscript c, where your A subscript m here simply stands for your what? Your modulating amplitude. Modulating amplitude. Your modulating what? Amplitude. While your AC simply stands for what? Your carrier amplitude. So your carrier amplitude. Am I communicating? Now, after defining your modulation index, remember, we are looking for what? An expression for what? Amplitude modulation. Now, from what we have here, we can bring out what is AM, which is amplitude modulation. So let's do that. We can calculate for AM. And what's your AM? Your AM will simply be what? M multiplied by what? AC. This is over 1, right? So what do? You cross multiply. Cross multiplying your AM multiplied by 1 is simply what? AM. And your AC multiplied by M is simply what? M what? MAC. So let's asterisk this equation. Just asterisk this equation here. Now, what's the next thing? Your step 4. Your step 4 simply says what? Apply your modulating amplitude principle. And what's your modulating amplitude principle? It simply says what? Your AM plus what? M of t. AM plus what? M of t. And what is M of t? M of t is simply what? Modulating what? Signal. Am I communicating? Modulating signal. Now, what is here? We are simply seeing what? Thus, your amplitude modulating signal is now given with this expression. Your modulating what? Amplitude frequency is now given what? With this expression. So for your step 4, you simply have 2 in 1. Your step 4 is what? 2 in 1 process. Now, what are the processes involved? The first process is your what? You're given what? Your amplitude modulating principle to be what? AM plus what? M of t. Now, since we have amplitude modulating signal here, you are now asked, what is now your amplitude modulating signal? Now, your amplitude modulating signal is now given by the expression S of t is equal to A of c plus what? M of t cos WC of t. Where your AC here simply stands for your what? Your carrier what? Amplitude. Your M of t simply stands for your what? Your modulation signal. While your WC simply stands for your carrier angular what? Frequency. Am I communicating? But remember, we had an equation for what? Modulating signal. And we said your modulating signal is what? AM cos WMT. Remember that equation. Let me show you the equation here. Now remember, we had an equation for what? Modulating signal. What is the equation we are seeing? We are simply what? Recalling this equation. That's what we are doing there. We are simply recalling this equation. Now, recalling this equation, what did we now do? They simply what? Recall the equation that M of t here is equal to what? AM cos W subscript M of t. We already know what the parameters are, right? We already know what the parameters are. Now, what you simply do is, look at what you have here. What you have here, take it back to this equation you have here. Impute it into this equation. So it's just like, let's take it, look up here. You simply have your ST is equal to AC plus what? M of what? T into cos WC of what? T, right? Now, they said instead of using modulating signal here, impute the equation for modulating signal into this equation. Now, if you impute the equation for modulating signal, we'll simply have that your AC here plus what is now your modulating signal, AM cos what? WMT. So you have AM cos what? Cos WMT, right? Into what? Cos WCT. That's it. Now, are you done? No, we are not done. Why are we not done? We know what is AM. From what we've derived here, what is your AM? Your AM now is equal to what? M of C. So replace your AM here with what? M of C. M what? MAC. Now replacing that, this equation here will simply be what? This equation will simply be what? AC plus what? M, right? M what? What is your AM? MAC cos what? WMT cos, what's the last one there? Cos what? WC what? T, right? Sorry, it's not very clear. Now, forget the bullshit you are seeing here. Let me erase this bullshit now. Let me erase this bullshit. Let's complete it here. Okay, I cannot erase it. Okay, since I cannot erase it, forget what you have here. You get confused. Now, from what we have here, we've already replaced your parameters in this equation, right? Now, look at what you have here. You're having common terms, AC and AC. So what do? That simply tells you is take your common terms out. Take your what? Your common terms out. Taking your common terms out, you will simply have that your SC, S of what? T is now equal to what? AC, which is the one out, into AC into AC is 1. So we have 1 plus, what is your AC? Your AC is coming out. So you are left with what? M cos W M of T. So you are left with M cos WM of what? T cos what? Cos WCT. Now, what are you seeing here? Is it not the same equation? So this is the expression you want to arrive at. This is what? The expression you want to arrive at. That is what we have here. Now, looking at your expression, remember, why did we factor out? Why did we remove your AC here? We remove AC because we want to apply this principle here. What's that a principle? We want to apply this principle which we have here. We want to apply which of the principle? We remove AC because we want to apply this principle here. This principle is very important. That was why we remove what? AC. Because what you have here is simply telling you your amplitude modulation. Your amplitude what? Modulation. That was why we remove your what? Your AC, and we imputed what? This equation. And after imputing that equation, we arrive at what? The expression for what? Your AMDSB, which is your amplitude sideband. So if you see that equation or you see that question in the exam, you should know how to go about it. Am I communicating? So this is your expression for your double amplitude modulation of your double sideband. Now let's go over to the next question. What's the next question? The next question simply says what? The antenna current of AM transmitter is 12 amp. The antenna current of what? AM transmitter is what? 12 what? Amp. Now, when unmodulated, when what? When unmodulated, but increases to what? 13 amp. When modulated, calculate what? Percent M. What is your percent M there? They're not asking you to calculate for your what? Your modulation index. This should tell you that you are asked to what? To calculate for your what? modulation index. What you have here, this should simply tell you what you are to calculate for what modulation index. That is what you are now asked here. Now, how do you go about calculating for your modulation index? Remember, the equation we know for you to calculate for your modulation index was what? PT is equal to what? PC, right? Into 1 plus what? M square over what? 2, right? But remember, this equation, this question, we are not giving PT. We are not giving what? PC. But what are we giving? We are giving current. We are giving what? Current. We are giving the first current to be what? Carrier current. Your carrier current is what? 12 amp. So we are giving your carrier current to be 12 amp, and we are giving your modulated what? Current. Now your modulated, when unmodulated but increases. So this is telling you that we are giving what? Our transmitted what? Current. So your transmitted current, your IT, will now be equal to what? 13 amp. So what you should ask yourself is, how do we solve your modulation index with our known parameters? Right? Remember, if you go through your material, you will see an equation that says what? Your IT is equal to what? Square root of what? 1 plus what? M square over what? 2. So instead of seeing what? A closed bracket, we are now seeing what? Square root, when we are considering what? Current for what? Your carrier current and your transmitted what? Current. So this is the equation you have to use. This is the equation you have to use. Sorry, something is missing. What is missing is your IC. Remember, this equation here is having what? PC. So what you have here should be what? IC. Sorry. So this is what? This is IT. So you have your IT here. So you have this is equal to I what? IC multiplied by the square root of what? 1 plus what? M square divided by 2. Where your M square here, your M simply stands for your what? Your modulation index. Now look at this equation. What do you think you are going to do to simplify your equation here? What do you think you do to simplify your equation here? We can simplify this equation by squaring both sides of our equation. Square both sides of your equation. Now, squaring both sides of your equation, this will simply give you what? This will simply tell you that your IT, you will now have your IT square is equal to IC square into 1 plus what? M square over what? 2. So we are going to square these two. Are we going to square this? We are not going to square this because that square is removing your square root. So in essence, your square here will be cancelled out. So you have your equation to be IT of, so you are removing this square. So you simply have your IT square is now equal to your IC square of what? Your equation given. Remember, our interest is to get what? Your modulation index. Your interest is to get your modulation index. So what do you think you are going to do? Now, to get your modulation index, we can take IC to this other side of the equation by dividing through by what? IC square. So we are dividing through by IC square. We are dividing here by what? IC square. Now, if you do that, you simply have that your IT square divided by what? IC square is equal to, this is equal to what? 1 plus what? M square over what? 2. Right? Now, if you do this, remember, what are we looking for? Is your what? Your M square. That's our interest. Our interest is to what? To get what is your what? Your m square. Now, how do you go about getting your m square here? Now, from what we have here, we can simply say what? For you to get, let's remove this bracket. Removing this bracket, we are actually simplifying. Let's simplify this further. This will simply give you I square of t divided by I square of c, and this is equal to 1 plus what? M square over what? 2. Right? Now, we can make m square subject here. We can make m square subject, and we can take this to the other side of your equation. Now, if you take this to the other side of the equation, you simply have that your m square over what? 2 is equal to what? It square divided by what? I square c, subscript c. And this will be what? Minus, because this is crossing an equality sign. So you what? Minus 1. Right? Now, since you have minus 1 here, you are still seeing what? 2 here. We are not done. We are not done. This is the same thing as writing 1 over 2 multiplied by m square, and this is equal to what? It square divided by what? I square, I subscript c of what? Of the square minus 1. Now, what do you do to this side of the equation to make m square stand alone? We can make your m square stand alone by multiplying this equation with what? 2, and we multiply this equation with what? 2. So basically, if you multiply this equation with 2 and you multiply this side of your equation with 2, this 2 is actually eliminating this, and you are left with what? Your m square to be equal to what? I subscript t square divided by what? I subscript what? C square minus 1 multiplied by what? All is multiplying what? 2. So basically, from what we have here, you can solve this equation by imputing the values. Imputing the values there, you simply have that, though if you want to simplify this further, you can have that your m will now be equal to the square root. Your m will now be equal to the square root of what? It square divided by what? Ic square minus 1 multiplied by what? 2. Am I communicating? So what do you do? The next thing you do is to impute the values, and you get the value for your m without wasting time in the exam. So now we have m will now be equal to square root, right? So we have square root. What's your it? What's your it? Your it here simply stands for your transmitted current, and your transmitted current was given to be what? 13, right? So you have 13 square, because of the square we have here, divided by 12 square, right? Minus 1 into 2. So 2 is multiplying everything here. Now, after getting what you have here, you multiply it by what? 2, and you take the square root of your answer. Now, if you take the square root of your answer, I think you are going to arrive at 0.589. I don't know if my calculations are correct, so you do your own calculations and drop it on the comment section. So if my calculations are correct, you can say all right. But if the calculations are wrong, if the calculation for your modulation index is wrong, drop the correct answer in the comment section. Now remember your modulation index. We used to say okay, let's recall. Normally they are giving your modulation index in percent, right? So we say modulation index to be 90%. What do we do? 90 divided by 100. That's what we used to do, and we said this is what? 0.9. So since we have your modulation index to be what? 0.589, what do? You simply what? Multiply this with what? 100. Now if you multiply this with 100, you will now simply arrive at what? 8.9%. So this is the answer you are to get for this particular question. This is the answer you are to get for this particular question. So for your question here, you can now say that your modulation index is now what? 58.9%. Am I communicating? Now, what's the next question? The last question, the last but not the least. Is it the least? Yes. Now, like, yes, it's the last, but I don't know if it's the least, sure. But we have the last question there. And what's the last question there? The last question there simply talks about a transmitter with what? 10 kilowatts. 10 kilowatts. What should that tell you? You are simply giving what? 10 kilowatts. So kilowatts talks about what? Power. Kilowatts talks about power. Now, what do you think you are giving? What are you now giving? Remember, you are giving percentage here. So you bring out the first thing which you are giving to be what? Modulation index. So now you're giving data. Let's look at the data given. The first thing which you are giving is your what? Your PC. Your PC. How do we know that this is PC? Carrier. The power given is what? A carrier power. So we have PC here to be what? 10 kilowatts. What's the next thing? Transmitted 11.2. So we are giving our PT to be what? 11.2 kilowatts. So without anybody telling you, you already know your parameters which you are giving. What's the next parameter which we are giving? We are now giving another parameter. They said calculate the MOD. MOD simply stands for modulation index. If the carrier is simultaneously modulated with a sine wave at what? 50% modulation index. So basically, you're not seeing what? Simultaneously. So that tells you that you have your first modulation index and your second what? Modulation index. Am I communicating? You have your first modulation index and your second modulation index. But in your question given, you were giving your what? Your first modulation index. And your first modulation index is not given, but we are giving our second modulation index to be what? 50%. So now we have our M1, which is unknown, and we have our M2, which is what? 50%. And what's your 50%? 50 divided by what? 100. And you have what? 0 point. Is 0 point what? Drop it on the comment section. 50 divided by 100. Drop your answer on the comment section. Let me see if you are following. Now, since you are giving your you are not giving your 2 modulation index, your interest is to calculate for your M1. Now, remember, we are not done. They said what? Calculate the total transmitted power. They are now asking us again to calculate what? The total transmitted power. Now, before we calculate for the total transmitted power, let's first of all calculate for your M1. Let's first of all what? Calculate for your M1. Now recall from the question we are giving what? PC and we are giving what? PT. So what equation are we to use? We are to use the equation which you know that what? PT is equal to what? PC into 1 plus what? M square over what? 2. Right? Now if you've gotten this equation to be this, remember we have what? Pending what? M1, which we don't know. We have what? Pending M1, which we don't know. We already know what? Your M2, and your M2 is what? 50%. It's very constant. It is what? 50%. So what do you think we are going to do in this case? What do you think we are going to do in this case? Now, from what we have here, we can impute the values and see if we can get M1 here. Now, imputing the values, we know your PT here is what? Your PT is 11.2, and this is equal to, what's your PC? 10, right? So we have 1 plus M square divided by what? 2. What's your interest? Your interest is to make M1, your interest is to make M subject here, right? Now, making M subject here, what do you think we are going to do? Remember, we did a similar stuff like this. So why don't we just go over to what we did? Impute your values and you get what your M is. Now remember, what is this? What we have here is simply what? a kind of a representation of what we are to do there. So now this is simply what PIT. Now for this, for your question there, it will now be what PT over what PC minus what 1. Remember, this square, this 2 came from somewhere we don't know entirely. These 2 came from somewhere we don't know entirely. So where can we see the 2 coming from? Now let's look at your equation very well. You can see that your 2 is coming from this 2 we divided with. So you now have, in this case, we now have what? Go back to your question. Now going back to your question, in this case, we now have PT divided by what? PC, right? What's the next thing? Is it subtracted? Subtracted by 1 multiplied by 2. So in this case, we now have that PC is 10, right? So we have 10 divided by, what's your PC? So PT is 11. So we have 11.2 divided by what? 10, right? Minus 1 into 2. Now remember, what we are doing here is what? M square. We are looking for M square. That's what we are looking for. We are looking for what? M square. So what do you think your M square will now be? What do you think your M square will now be? Now, your M square, punching your calculator, I think you arrive at 0.24. So your M square here, your M square will simply be what? 0.24. Now remember, we are not going to square this. We are not going to square this. Why? Why we are not going to square this is because what we are given here was, they said what? Modulating power of a single sine wave. Calculate the modulation index if the carrier is simultaneously modulated with a sine wave at 50% modulation. So in essence, they are telling us that what we have here is what? M square of 2. We have to look for M square of 1. So what do we have here? What you simply have here, you simply have that you've already calculated for your what? Your M1. So your M1 square will now be equal to what? What you have here. Remember, since we are given M1 and what? M2, why don't we look for the total? Looking for the total, what is that telling you? That will simply tell you that you are looking for M square subscript T, and this is equal to what? M1 square plus what? M2 square. And that will give you 0.24, right? 0.24 plus what? Your M2, which was given, was 50, right? And what is 50%? 0.5. And we are going to square that. Now this is what? This is not having square because this is what we calculated for. But this is having square because it is what? It was given to us as modulation index. So what we do is you square it. Am I communicating? So you are going to square it. So here, so what you have here, the parameter you have here is not actually what? The parameter you have there is not actually square, sorry. So you are removing this square. So we are just given to be your modulation index, to be just M2. That was what you were given. And this is what I told you, drop it on the comment section. Do well to drop it on the comment section. Now, what do we have here? We simply have what? 0.24 plus what? 0.5. Now, if you punch that with your calculator, you will simply arrive at what? You simply arrive at 0.49. Remember, this is what? Mt square. Mt square. So what do you think we are going to do to make MT stand alone? So we know that that is our total modulating index. So your MT will now be square root of what? 0.49. Now if you check the square root of 0.49, that gives you what? I think that's 0.7. 0.7. If you punch your calculator, you get 0.7. So what do you do? So since you've gotten your modulating index to be 0.7, look at your question given. You now ask another question. After getting your modulation index, there was another question added there. They now said calculate for the what? Total transmitted power. So here now, they now said use this new modulating what? Index, which is your total modulating index, to calculate for your what? Your total transmitted power. So in essence, let's change the marker so we'll not get confused and take it step by step. Now from what we have here, we now have our new M here to be what? 0.7. Take this to an equation. PT is equal to what? PC, right? 1 plus what? M square of over 2. This is the equation, right? Now they're not telling you to calculate for your new transmitted power, the new total transmitted power, which is this. So you now have that your PT will now be equal to, what is our initial PC? What is now your initial PC? Your initial PC was what? 10, right? 10 into 1 plus, what's your M here? Your M is not 0.5 nor 0.24, but in this case, your M is now what? 0.7 divided by 2. This is square, right? So what you do is you punch your calculator and you get your what? Your PT. And what's your PT? Your PT in this case is now what? 12.45 kilowatts. Don't forget to always put your units. They are very important. So I think that is the end of your first section, which is just your section A. So we'll be able to solve questions from our section A, the question 1, question 2, and question 3. Do well to go through what we've done, and don't forget to always subscribe to get more content like this. Thank you.